Reroute the data stream through this node for better scalability.
Good idea. Deploying the workflow now.
Machine learning models provide zero business value as long as they remain isolated inside local, static Jupyter notebooks. To solve this, we are building a live application backed by a FastAPI backend, managed in GitHub, isolated in containers, and deployed via an automated pipeline. You will need Python 3.8, a local Docker desktop, a secure GitHub account, and a cloud tier to host your final model. Architecting these automated pipelines transitions your workflow from experimental scripts to reliable, production-grade engineering. We start by wrapping our machine learning script in FastAPI to create a RESTful predict endpoint that can receive web requests. Inside our script, we use Pydantic to define the expected data structure. This automatically validates incoming requests before the model begins processing. Start the local Unicorn server and open the auto-generated Swagger page. From here, you can send a test JSON payload and verify the prediction response. Now we establish our safety net. Automated testing is a mandatory requirement before any code is allowed to reach a cloud server. We write 2 Pytest checks, one to verify the model's mathematical inference, and another to confirm the API returns an HTTP 200 success code. Execute Pytest in your terminal. We are looking for a 100% pass rate across every inference check. If these tests fail, our future pipeline will block the deployment, ensuring that broken code never reaches the end user. Docker eliminates environment conflicts by isolating the API and the user interface inside their own completely portable containers. We write 2 separate Docker files to define the exact environment requirements for both the backend and the frontend. A Docker Compose file acts as the bridge. This specific line establishes the dependency routing, ensuring the frontend knows where to find the API. Run Docker Compose up to build the images. Verify that the frontend can successfully communicate with the backend on your local host. Containerizing the system provides environment parity, ensuring the application utilizes the same libraries on the cloud server as it does on your laptop. Now we automate the labor. Every time you push code to GitHub, our pipeline will trigger an automated testing sequence. Our workflow configuration defines the trigger events. It sets up the Python environment and runs the Pytest suite against every new commit. Watch the pipeline run live in GitHub. When the Pytest gate passes, the workflow proceeds to the final deployment stage. Never hard-code cloud API keys directly into your scripts. This is a severe security risk that exposes your infrastructure. Secure your credentials by navigating to your repository settings and injecting them as encrypted GitHub secrets. Once the secrets are in place, we add the final step to push the approved container to our cloud host after every successful merge. This pipeline eliminates manual intervention during the deployment phase, creating a repeatable, secure process for moving code to production. Open your live cloud URL, input a test payload, and confirm that your model is now delivering predictions on the public web. You have now established a scalable, zero-touch deployment architecture, moving beyond isolated local scripts to professional systems engineering. This same robust architecture can be adapted to serve complex large language models or any other real-time inference task. Subscribe to keep mastering the engineering systems that power modern artificial intelligence in production.